Hey guys, it's Jensen, and so for today, oh wait, it's not it. For today, I'm doing the air rocket activity for Mr. Day. Hey, 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 hey. Okay, it says here for the directions, an air rocket is shot straight up into the air. No engine rocket is in free fall, and it falls back to the ground where it was launched. The rocket is launched with a low, medium, high, and super cap. Measure the time for the rocket to go up and come down for each cap, and then complete 1 to 10 below on a separate piece of paper. Explain your answers in a screencast, which is this, and paste your link to the screencast on class website, which I will do shortly after this. It's number 1. Sketch a diagram of the situation and use arrows to represent the velocity position. And so what I see here for low is that you can see from here that this is the low. So my time was 4 seconds, medium is 4.0 seconds, high is 5.87, and super is 6.49. And the acceleration of going down of the Earth is 10 meters per second. And the velocity in position, which is not yet shown, because we'll get to that later. And so, for what we can see, for what we know, going up is the positive direction, and going down is the negative direction. And you can see here also, the time for the diagram for the medium is 2.09 seconds. Going up and going down direction, acceleration is 10 meters per second. So here's the same thing for high and super, except for high it's 2.935 seconds, while super is 3.245 seconds. They're both going up in the positive direction, one going down negative direction. The acceleration for both of them is going down, which is equal to slowing down, or 10 meters per second. So, which is around 10 meters per second. Moving on to 1707. 1707 is asking here to sketch a velocity versus time graph and acceleration versus time graph, and then use your graphs to figure out everything else below. What is the change in velocity of the rocket? Oh, I'm sorry, that's not it. That's number 3. But I just say asking to sketch the velocity time graph. As you can see here, all the four. Don't mind if you guys can see the folder thingy. Don't mind it. It's a bug here in my computer. But as you can see here, it's going up and down. Because as you're going up, you're slowing down, and as the rocket stops in mid-air, that is where 0 is. So basically, it's slowing down in a positive direction, and once it stops for a millisecond, and that represents 0, it starts going down, which starts speeding up at the negative direction, which is an overall total of 4.07. And here's the times, like the mid times, where the rocket stopped. Here, moving on to number 3, which is 1708. Number 3 is asking us the change of velocity of the rocket. In order to find the change of velocity, we have to use the area of the acceleration time graph. Since the acceleration of Earth is negative 10 meters per second, it's going down, and multiplied it by the overall time, you will get the final velocity. Moving on to number 4, which is 1709. As you can see, here is my explanation. In order to find the change of velocity, multiply the Earth's acceleration with the time received unit cost. Cross out to find out the final velocity. Number 4 is asking how fast was the rocket traveling when it launched. Now here it's asking how far it traveled, how far it was going. And so in order to do that, we have to go back to 1707. Yeah, we have to get back to. I'm sorry, that's not it. 1708, which is the wait, 1706, 1705. Oh, that's weird. Haha. JK lol. Okay, here as you can see here, we have to find the initial. So that's right. How fast it was launching from here to here, so that it can get from here to here, or from here to here, from 0 to 2, or whatever. But basically, from starting, how fast was it going? From going here to here, not going from top, not going for the whole duration of the rocket, which is from going up to going down. So going back to my Is that it? Yeah. Going back to that, we're just multiplying by half. So we're just multiplying the initial velocity, which is for low 10 meters per second times 2 seconds equals 20 meters per second. And that's for the low. For the medium, it is velocity is 20.4 meters per second. The initial velocity for high is 29.35 meters per second, and the velocity for the super is 32.45, as you can see. This is 17.09. So I'm just saying the numbers here right here so that I won't get confused. And here's my explanation for number 4. In order to find an initial velocity, you need to have the overall time of the rocket to measure from where it started to increase in the negative direction. So that's what I just said like a while ago. Number 5, it's asking, is the speed when the rocket was launched different from the speed just before the rocket hit the ground? Explain your logic. No, I said no, the speed was the same. Since the speed was the same was when it went up and when it down. And meaning, if you go up 20 meters per second, you will go down 20 meters per second. If you travel 20 meters up, you will travel 20 meters going back down. It's symmetrical. It's physics. Number 6. What was the maximum height of the rocket? In order to do that, we have to plug in the numbers from number 4. So when number 4, it's asking, what was it? 3, 4. Yeah, it's asking how far you went up going up. And it's the same. It was the same logic. This time, you're multiplying it. This time you're finding the initial velocity times the seconds it took from initial velocity to the highest. And to the highest, yes. And you have to multiply it by 2 because as you can see from the initial oops, that's not right. As you can see from the initial velocity time graph, we only have to find from here the highest point. So we just have to find in the area, this area, the triangle area. So if we go back here at 1711, that's not it. Hey. Here, 1710, we can see that you have to multiply 20 meters per second, the initial velocity, times 2, the highest it went up, going to the positive direction, slowing down the positive direction, divided by 2, which is almost the area, and is equal to, 20 meters. For medium, is 21.114. This is 1711. Highest, the high rocket is 43.1 meters, and the super is the 52.7 meters. Moving, it says right here also for. Did I write it down? Did I take a picture of it? Yes, and I also answered this. In order to find the maximum height, you need to use the area formula in order to see the maximum height, and by reference of the velocity time graph. Number 7, it's asking, what was the acceleration different when the rocket reached maximum height? Explain your reasoning. No, I said no. The acceleration was the same thing because as you can see, you're going down. As you can see from the velocity time graph, the acceleration never changed. It's always negative, or the slope of the velocity time graph is negative, and so therefore this acceleration never changed. Moving on, 1712. Number 8. What was the total distance of the rocket traveled? So basically, this time you're looking for the whole area, the whole thing. So the whole thing to get from here to here, back to here, back to 0. So you're looking for the whole overall distance. And since I got 20 meters per second, wait, is that correct? Since I got 20 meters from the highest point, how far it traveled, I will get. Well, that's not it. Haha. I will get 40 meters. I'm just adding another 20 because as I said, if once you're going up 20 meters, you go back down 20 meters. Same thing for medium, 42.228 meters. High is 86.2 meters, super is 105.4 meters. And it says right here, in order to find the total distance, get the final data for number 6, because it measured the first half of the launch, so it's a half overall distance. I don't know if that made any sense. 1714. We are on number 9. Number 9 is asking the total displacement of the rocket. So they basically, where is it finally? Where is it finally? Well, that's kind of tricky because you're finding the total displacement away from 0. And so in order to find that, you just have to multiply. Oops, that's not it. Well, basically, okay, maybe I can use this. So basically, from here, 0. Sorry, I'm using a mouse. So basically, you go up here. That's first distance. Then you go back down here, which is the final distance. That's the final distance. So what do we do now? So that's the final distance, which is the same thing as number 8, because it's the total distance. So therefore, it's the same answers. 40 meters per second. For low, medium is 42.228, high is 86.2, and super is 210 meters. And I just answered number 10 a while ago. Are your answers different from the last 2 questions? No, they are not. Because you're looking, as I've said, as you can see from this, you're looking for the final displacement where it is after it was launched, after it stopped moving. But you're already back in 0, so basically it's the same distance you traveled from the overall total distance. So that's pretty much it. Anyway,